Vedic mathematics, as you will know, was rediscovered in modern times by Sri Krishna Tirthaji, and he wrote a book of that title. And the subtitle is 16 Mathematical Formulae from the Vedas for one-line answers to all mathematics problems. And he gives a list of 16 sutras in Sanskrit. This is the list. Well, of course, this looks like a preposterous proposal. How can 16 formulae cover all of mathematics? And not only that, give one-line answers to all mathematics problems. Today I'd like to suggest an answer to this question. Tirthaji does give translations to most of the sutras, and here they are in English. And if you look at them, you find that there doesn't seem to be much structure. They seem to be obscure. Some have many applications and some few. And so, of course, a lot of questions arise about the validity and the use of them. What we need is a holistic answer to this question. And what I want to suggest here is that each sutra is a mathematical expression of a mental process. We all use the same mental processes, more or less, and mathematics is constructed by those mental processes. So it makes sense to look at these 16 sutras in terms of mental processes. And if you do that, in fact, you find that the first group of 8 can be considered an analytic group, and the second group a synthetic group. I'll explain all this as we go along. Also, we can divide further into 2 groups and get 4 tetrads. The word tetrad simply means a group of 4, so it's useful here. And each of these tetrads has its own function. The first tetrad generates ideas, results, data. The second organizes results, analyzes and compares. The third generalizes, and the fourth consolidates. I'll explain all this as we go on. So the analytic group is a process of proliferation, fragmentation, and the synthetic group, we get unification. So we start off with unity, we start off with some problem or question, and we come to a final answer at the end, which is our unification. To take an example, we could think of a class being asked to measure their heights and compare with the heights of the class next door. The first thing they would do is to find their data. They would measure their heights, measure all the heights, and put them together, and then they would begin to organize and analyze them, maybe work out graphs and means and things. And then they would start to draw conclusions in the third tetrad, and then maybe they'd write a project to consolidate the whole thing. So that's an example of how it might work. We won't necessarily use all the tetrads. Sometimes we just use 1, 2 or 3 or part of a tetrad, or just 1 or 2 sutras. These tetrads also have the same structure. So basically each one starts with an initiator. The first sutra in each group I'm calling an initiator. The next is a selection process, then an operation, and a result. So I'd like to show next these sutras in a different arrangement to bring out this structure and in fact the cycles that are contained in them. And it's like this, and to make it clear I'm going to show these sutras one at a time. So here's the first sutra, by one more than the one before, second, third. And they're going to form a cycle which is unified and gives a result. And so we have this fourth sutra that expresses that. And that happens in all the 4 tetrads. We have the first 3 forming a loop, a triangle, a cycle, and the 4th one which consolidates it. And the functions of these, as I've already said, generating ideas, data, organizing, comparing, generalizing, consolidating. Now let's look at these in more detail and how they actually work. So here in blue are the corresponding mental processes that we're going to be looking at. So in the first tetrad, basically you're just generating an idea. You've got a question and you get an answer. So the question might be find 45 times 45, and you select a method, an approach, and then you carry it out and you get a result, which you may repeat this cycle to check the answer, or for some other reason you might go around the loop again, or you might just stop. So that's how the first loop works. It just generates one answer to one question. But in everyday life we are involved with more elaborate considerations. We've got lots of ideas spinning around in our head, and that's this situation here in tetrad 2, where we have to deal with that situation. And the first thing we generally do is to eliminate a lot of the questions, a lot of the ideas. You may have heard of something called quantitative reasoning, which is a popular kind of exam question where you're given much more information than you really need, and you have to sift through it. You have to see how to find your answer by ignoring a lot of the information that's given. So that's the first sutra there. It enables you to just ignore all that. And then after that you're going to select one idea or a pair to compare and examine those and compare, and then go around the loop again until you're satisfied you've got an answer. And another example might be doing a Google search. I'm sure you've all done those, and the first thing you do, you get a lot of results, maybe millions of them, and you ignore most of them. That's this sutra here. And then you select one or two to compare and narrow down until you get an answer to your question. In tetrad 3 we generalize, and if you think about the process, if you examine the process of generalization in your mind, you'll see that it's carried out by selecting some quality or feature of an idea and looking for that quality in another space, in another area. And that's done here. So that is the process of generalization. And we all do it all the time, but we don't realize because it happens very fast and subconsciously. Constructing mathematical proofs comes in here. The first thing we do, we know what we're trying to prove. We attempt to find some way in, some feature of the problem that will allow us to encapsulate it algebraically, and then we carry out the proof and get the answer. Let's just go back to Sutra 2 for a minute. Earlier we said that select approach corresponds to all from 9 and the last from 10, and you may have been wondering why. Well, we can apply our generalization here to that sutra and see the connection. So all from 9 and the last from 10. 9 is the largest digit. After 9 we get 10, which brings us back to unity. So in a way 9 represents complexity and 10 unity, if you generalize. And by saying all from 9 and the last from 10, we're suggesting many attempts and one success, if you like. So 10 is the success at the end. The last from 10 is the completion. So it corresponds to considering a lot of options and selecting one out of them. Coming back to tetrad 3, what has calculus got to do with generalization? Well, perhaps the simplest illustration of differential calculus is if you imagine a circle and a line cutting the circle in two places. Now imagine that the line turns, it rotates around one of the points, then the other point will gradually move around the circle and ultimately coincide and merge with the point of rotation. So this is the perfect example of two becoming one, which is essentially what differential calculus is all about, and integral calculus does a very similar thing. So when one point merges into the other, it's like a specific quality being located in a larger unity. So this is generalization, and a more expressed version of that is tetrad 4, in which we begin to consolidate and bring things together. And a good example of that is in perhaps there's a conference, a Vedic Mathematics conference, and you have to sum up at the end. So you're going to briefly consider all of the presentations that have been made and demonstrate how they've been related to the aim of the conference, whatever that is. So the ultimate in that example would be the conference aims, and the penultimate will be the one that's being consolidated. And then you would go on to the next one, and gradually they'll all be consolidated and absorbed into the presentation you're giving, and your explanation is the product of the sums, where you're consolidating them. And then you would go around to the next one until it's all complete, and that's where you stop. So, to sum up, mathematics is constructed by our natural mental processes. The Vedic Sutras describe these processes in mathematical terms. They are ordered, structured, to describe the way we think, from specific to holistic, through those four tetrads. They have mental as well as mathematical applications, and their structures provide a framework for rational thought, essential in all areas of study. So I'd like to suggest that what Tirthaji has given us is a system of sutras that not only describes all mathematical processes, but also all rational thinking.